Hi, I'm Hadrian Da Vinci, and today I'll show you guys how to speed Python programs up using Cython. Cython is good for two reasons. One, it allows you to compile Python programs into C or C++, and then two, it allows you to import compiled C or C++ directly into Python code. And this is a really big deal because it opens up the door for many performance enhancements. So let's take a look. So we'll first start off by installing Cython onto our system, and then next we'll create the necessary files that are needed for this tutorial. Then after that, we'll do a comparison between regular Python and Cython to see which one is faster. So let's discuss how Cython works. So how Cython works. And I actually have a picture here that I want to share with you guys. There it is. Big picture wise, we have a .pyx file. This is exactly the same thing as a .py file, with the exception that you can use C types. And I'll get into more of this later on, but just know that this .pyx file gets converted into a .c file. And then you can compile this file to a .so file, which is an executable for C on Linux, or if you're dealing with Windows, when you compile that, you get a .pyd file. Now what happens here is when you have these executables, you can then import this within Python, which is pretty cool. And then you can access C directly from your Python code. So this is how this works. Okay. So let's install Cython onto our system. Install Cython. So if you want to install Cython, the command that you're going to need to use is this one. So let's see, I'm going to prefix this with an exclamation mark to denote that this is indeed a bash command, so I'll do pip, and let's see, it's pip install Cython, and then we'll have a -- install option, and then we'll set this equal to, let's see, -- no Cython compile. So this is what we want to run to install Cython. And let's give this a shot. Okay, so as you see here, all this is telling us is that I already have Cython installed on my file system and there's no need to reinstall. The next part of this process is to create files. Big picture wise, the goal here is to create a function called integrate, create one version for Cython, create another version for Python, and then import this within a file, which will do a comparison between the Cython version and the Python version. So that's essentially what I want to do. So first, let's create a file for the Python version. So create integrate code for Python. And then once we do that, we'll create, I'm going to copy this and paste it below. Create integration code for Cython, and then we will create a setup.py file. The reason why the setup.py file is needed is because we want to compile that Cython file into an executable that we can then import within Python. So create setup.py file to compile Cython code. And then the last file that we need to make here is create file to compare Cython, compile Cython code with Python code. Alrighty, so that's what we want to do. 4 different files. Let's get started. So here I'm going to create a file, and let's call this file code.py. So again, we're integrating, and in integration, we need a function to integrate. So let's call it function to integrate f, and f takes an input, which is x, and all this function does is to return x squared, or x times x. That's all it does. This is also called a quadratic function or parabola. And then we need our integration function. So we'll call this function integrate. Integrate. And during integration, all that's happening is that we're finding the area underneath our input function. That's all that's happening. And that area is being found between some interval, a and b. So that's how it works. And n represents how many iterations you have. N could be 4 or it could be 1,000,000. This is how many tiny slices you have underneath that curve. So let's see what we need. So I know that I need an area. I'm going to initialize that as 0. Then I need a dx. Dx again represents those tiny widths. Think about a rectangle. You have your length and width. Dx is your width. And we are going to define our width as b, which is the end of our interval, minus a, and this is going to be all over n, the number of increments. And then we want to loop through. So we'll do for I in range n. So this is between 0 and n. We want to keep on adding to our area. So I'm doing plus equals. And every single time we are adding the height of that mini area, which is f of x, times the width, which is going to be dx. So we don't have x defined yet, and let's define x. So x is going to be equal to the starting point of our interval, which is a, plus I, which is the index, times dx. So that's what x is. So let's see, what else do we need here? So at the very end, we need to return our area. And that's it. So this function represents the integration of whatever your input function is, right? So that's what we have. So next, the next file that I'm going to create is really the same thing that we have here, but the only difference is that I'm going to modify this so that Cython can do improvements to increase the speed. So first I'm going to save this, so save file, and then I'm going to copy my code.py, and let's rename this. So rename, and we'll call this code.pyx. Perfect, let's take a look. Now, like what I said, we want to make some modifications so Cython can speed this up. The first modification we're going to do is we're going to denote the type of variable. So looking at our input function here, x can be a float. So we're going to call this a double. And what else do we have? Here we have a, b, and end. Both a and b, the beginning and end of this interval, both of these can be floats. So let's call them doubles. So we'll call this double. Call this double. And n should be an integer. It's the number of iterations that we have, or number of subdivisions that we'll have. So we'll call this integer. So what else do I need? So I see that we have area. I need to denote that type. And then we have dx, and then we also have I. So what I'm going to do here is I'm going to, let's see, I'll do I is an int. And also one thing that you must do when you're using Cython is that you have to use cdef. So we'll do cdef int I. And the cdef indicates that we're dealing with the C type. And then also we'll do the same thing for the other ones as well. So we'll do cdef double, and area is a double, x is a double, and then dx is a double. So x, we're using x here, but we still have to define the type of pair. Same thing with dx. So let's see, I'm checking to see if I'm missing anything. Okay, so we define the types. We have to do the same with the functions as well. So with Cython, if you don't intend on exporting that function, then you should really call it a cdef, because that way the compiler can do optimizations to make it even faster. So here we have this input function. I'm going to call this cdef because my intention is to not import that within the code that I'm using for comparison. So this is a cdef, and then this other function that we have for integration, we're going to keep this as a def, because again, I do intend on importing this function which integrates. So I just saved a while ago. Let me check to see if I'm missing anything. We have area, x, dx, and I. Okay, looks good. So now that we've defined our Python version of that integration function and the Cython version, the next thing to do is to create a setup.py. This setup.py is important because this is how we're telling Cython that we want to take our code.pyx and then compile that into C, or really an executable of C. So let's create that file. Come here, and then we'll do create a new file, call this setup.py, remove the .txt, and save. All right, great. So for the setup.py, I actually have one here that I've used. So I'm going to paste this over here and then explain what's going on. So here from lines 12 to 15, we are saying that we want to export this as code CY. And here we're taking the code PYX file, which is here, and we are exporting that as code CY. So that's all this is doing. So now that we have the setup defined, the next step is to actually run this. So that way the setup.py will create the build and create the executable that we can then use to import in the next step. So let's go back to our Jupyter notebook here, and we will let's see, we will compile. So we'll do compile code.pyx, and we can do that by doing this command. So we'll do exclamation mark to denote that this is a bash command, and we'll do setup.py and build underscore ext dash dash in place. All right, perfect. So let's run this, and if this works correctly, we should actually have a build over here on the left side, and we should have the compiled version of our code.pyx. Let's try this. All right, let's try this again. Let's see, do print. Okay, that worked. Okay, I see what happened. So I needed to remove the space between the Python and the exclamation mark. So let's say, let's take a look and see what happened. So it says that compiling code.pyx because it changed, and it has a warning here, but I think it worked. So on my right side, or not right side, on the left side, we see here that we have the build, we have the code.c, we have the code.py, which is the original. And then you can't see it here because Jupyter Notebook's not showing it, but there's some other files that are in this folder. And these files are the ones which were also built during this process. All right, awesome. So now that we have compiled our code.pyx, the next step is to create a code that we can use for testing. So we're going to make a file called compare.py. So come over here and we'll do new file. Let's call this compare.py. All right, awesome. And in this file, we're going to do a comparison via timing thing. So I'm going to import time. I'll do from time, import time. Remember how we're integrating between A and B, right? So I'm going to define A as 0 and then B as 10. And let's make N equal to 20 million. So 20, 1, 2, 3, 4, 5, 6. All right. So this first block of code, we want to run the integration via the Python code. So we'll do run integration via Python integrate function. And let's see, we'll do print from Python. So this way I can tell that the Python code is running. So print from Python only. And then below, we will do a, we're going to import the file that we care about. So we'll do from code import integrate as, let's call this integrate from Python only. All right. Now that we've imported our integration function here, we will then start the timing process. So we'll do T1 is equal to time. That gives us the current time. And then we'll do something. And then we'll do T2 is equal to time. And then we're going to print the differences between those times. So we'll do print. I'm using this as a format string. Took T2 minus T1 seconds. Okay, good. Now, what we need to do is right here between T1 and T2, we need to run that code of interest. So we'll do, what is it? We're doing integrate. In fact, let me copy this. It's faster. Integrate from A to B, and we're doing this n times, or with n iterations. And what I will do here is I'm going to print the value that we obtained from that function. And then here I'll do run integration via Cython integrate function. And here we'll do from code CY. And by the way, I want to highlight one thing here. So this is why I wanted to name this something else, because as you see here, we have code and then we have code CY. If this were called code, then I would have a conflict. And I think when this happens, Cython imports the, it has a preference for importing the compiled code. Okay, so from code CY, import integrate as, so we'll call this from Cython. Okay, and we will run the same thing, same parameters, but a different function. Alrighty, so it looks good to me. Next, I'm going to jump back into our Jupyter Notebook, and we will run this. So we'll do, let's see, making this into Markdown, and say run compare code. And here we'll do Python compare.py from Python only. Perfect, yes. So, two things. One, it's easier to see the difference between the Python code block and the Cython code block. Number two, yeah, so Cython's definitely faster. And Cython is a really great tool to use in order to get performance enhancements. And what's important is that Cython will allow you to connect your Python code to C code.